Hey guys, so in this section we're looking at multiplication and division with rational expressions. The steps are going to be pretty similar to the last section where we basically just factor and cancel. This is going to be a little bit more factoring, and I'm going to do a couple of easy examples to start off just to remind you how multiplying and dividing works with regular arithmetic fractions, because our steps are basically the same here. So if I was going to multiply these, a lot of times what people will do is they'll just multiply straight across and then start having to reduce the big fraction. Maybe an easier way to do that is to kind of look and see if we can factor. And so I see the 10 and the 9, and if I think of this over here as 9 times 3, and I think of this one as 10 times 4, and I could factor the 9s down to a couple more 3s and the 10s to 2s and 5s. But you can kind of see what's going to happen is I can just reduce right now and get 3/4. And so I never end up actually multiplying anything, I just cancel. I basically factor cancel. For division, it's just like multiplying, except that we have to remember to take the reciprocal of the second fraction. So we'll just rewrite this as multiply. And now I can do my factoring. So 6 I'll write as 3 times 2 over 7. 21 I'll write as 3 times 7 over 2 times 2. So that time I factored all the way out because it was helpful. I cancel the 7s, I can cancel some 2s, and then what's left would be 3 times 3, 9, and then just a 2 on the bottom. So again, you can see there's not much in the way of multiplying. It's mostly just factor cancel. So that's what we're going to see in this next section. So this first one, I think I will rewrite it, and I'm going to get this division flipped over, and I'm going to get kind of my numbers lumped together and my letters in alphabetical order. So this is going to go 55 times 18, and then this flips over. Sorry, I got a siren there. And then times 7. I feel like I should probably, I'm going to rewrite it with it flipped. I think it's going to look better. So we'll do this. And then with that division, I'm going to go ahead and flip it over and have 7z squared up top now and 5x below. So I can actually kind of cancel from right here. If you look at the 55 and the 11 and the 5, well, 11 times 5 is 55. So I can knock those out. And then I got 6 and 18, so 6 goes into 18 3 times. And so you can see I didn't really have to end up multiplying much. I'm going to go 3 times 7 and get the 21. But that's about it for the multiply. And then I'm just going to kind of write these in order just to show the canceling a little bit cleaner, a little bit easier to follow, hopefully. You could certainly do it back here. This is just for clarity. So I just kind of copied over all my variables and put them in order. And so now do a little reducing. There's that rule that says you can subtract the exponents 2 minus 1, we'll leave x to the first. Invisible 1 minus 3 would be y to the negative 2, but then you have to move it downstairs. So really I think of it more as canceling. I think of this as like a couple x's up top with an x on the bottom, so we have 1 up, y over y cubed. So I think of that kind of more like this, so we're going to have a y squared downstairs. And then 2z's up, 5z's down, so if I cancel 2 of them, I should have z cubed downstairs. This next one is a bit more like what we'll see for the rest of this section. There's a couple of these at the start, and it's mostly like this. So this one's a division, so we're going to want to flip this over. I'm not going to rewrite it all and show that, so I'll just kind of factor and flip at the same time. So our steps for this are basically factor and then cancel. And if it's a division, then you want to flip the second fraction first, do the reciprocal, and then factor and cancel, and that's it. So, and we don't have to worry about variable restrictions in this section either. It's just trying to simplify this. So with this x squared minus 16, I'm going to write that as x plus 4 and x minus 4. 5x minus 20. This is the too easy, it's hard. People miss this a lot. And it's just because it's just a little GCF of 5. But when you skip over that, then things don't cancel right. So careful to look for those. And they'll show up kind of all over the chapter. And now since this is divide, I'm going to rewrite it as multiply. So I'm going to bring this 10x plus 10 up. I'll take out a factor of 10 while I'm there. And then this is downstairs. We need what two things multiply to 4 and add to 5. So that is going to be x plus 1 and x plus 4. And so then once I do that, oops, sorry about that. Once I do that, I just cancel everything that's common top and bottom. So minus 4s are gone, plus 4s are gone, plus 1s are gone, and I got 5 into 10 twice. So for that whole mess, the answer is just in reduced form 2. It's not that x equals 2, it's just that no matter what number I put in for x, this is always going to come out to 2. Okay, these two are problems I'd have you guys try in class. So here, I probably wouldn't try to multiply any of that out, the 5 and I'm just going to flip it over right now, maybe try to, I'm not going to try to write things in order. I'm just going to flip it over. So now it's going to be multiplied by 18x 5 y 3. And then downstairs we'd have 25x y to the 5th. And so I can look right here at the coefficients and go 5 goes into 5 once, 5 goes into 25 5 times, and 9 goes into 9 once, 9 goes into 18 twice. So I know I'm going to have a 2/5 out front. And then I have kind of x's and y's all over the place. So I'm going to group them together first, and then I'll do my cancel. So squared and 5th would be x to the 7th up top. And I got 3 and 3, so y to the 6th. Downstairs, a couple of x's, so x squared, and that would make y to the 9th. And then it just is easier to see how to cancel. So I'm going to have a 2 up top, a 5 downstairs, 7x is up, 2 down, it's going to leave me 5 in the numerator, and 6 up and 9 down, again cancel out 6, and that's going to leave you y cubed downstairs. For this one, so factor cancel, so x squared minus 1, that's going to be x plus 1, x minus 1. 2x plus 4, careful not to miss that 2. Just a little GCF. This would be what multiplies to 6 and adds to be 5. So x plus 2, x plus 3. And this is what multiplies to negative 3, adds to be 2. So x plus 3 and x minus 1. And then cancel everything, and what's left is your answer. So minuses are gone, x plus 3s are gone, x plus 2s are gone. And so just right there, x plus 1 over 2, that'd be it. Number 5 would be back to me doing it. Looking at kind of what's coming up, we got a couple of cube formulas, and I can just do those in place. Difference of squares, I can do that in place. But I'm going to go ahead and do some scratch work with this magic method one up here and just get it factored. For me, I like to do all the factoring kind of at once for each problem and then put it all back in at once. I find if I kind of bounce back and forth, then I make errors. So this is going to go 6 times negative 2 for negative 12. So I need to add to 1, so it'll be a 4 and a negative 3, or 1 apart. So this will be 6x plus 4 and 6x minus 3. And then I have to divide out that fake 6, so this will be 2 of it here and 3 of it there. That'll make, oops, not 6x, 3x plus 2 and 2x minus 1. So then I'll go ahead and rewrite all of this factored. So up top I'm going to have 2x plus 1, 2x minus 1, difference of squares. That's going to be over this result, 3x plus 2 and 2x minus 1. It's a division, so I want to rewrite as multiply, so the 27 is going to be top, and then the 8x cubed is going to be on the bottom. So for the 27, that's our cube formula, so 3x plus 2. If you need a refresher how I'm doing this, check out the 5.5 video. 3x times 3x is 9x squared. Opposite sign, 3 times 2 is 6x. And 2 times 2 is 4. And then same thing up here. So again, it's in the denominator because of the multiply. So 2x plus 1, 2x times 2x, 4x squared, and then minus 2x and plus 1. So right there with that problem, you can start to see why the factoring is so incredibly important for this class. If I cancel what's common, those go, minuses go, pluses go. And then right there, that would be my answer. And then remember with the cube formula, this cannot factor any further, so don't try to make it better. That's as good as it's going to be. Okay, so this next one is kind of a huge commitment. I'm just going to factor each of these kind of separately, and then way down here at the bottom, I'll end up putting it all back together. So let's see, if I do this first one, 2x to the fourth minus 16x, I can take a 2x out of there. And that's going to leave me an x cubed minus 8. And so for the sake of not writing this thing a bunch of times, I'm going to come down here with that and just write it out in place. So that's going to give me 2x, and then I'll do the cube formula again here, so that's x minus 2. Again, section 5.5, and a lot of people struggle with this, so if you're not quite following, you're missing a little bit of Math 94. So head back to section 5.5 in the factoring review, and that will help out with these. X squared, 2 times x would be 2x, and 2 times 2 will be 4. Looking at the denominator of that, I could take out, let me write down what it is. So then this is going to make, there we go, I could do a 3x squared out front, and I'll leave an x to the fourth minus 16. And then we've seen this one, this is going to be a difference of squares, but it's going to go a couple of rounds. So that'll be 3x squared, and then x squared plus 4, x squared minus 4. And then this is going to go to x plus 2, x minus 2. So I'll go ahead and write all that out down here. And then factoring this, x plus 2, x minus 2. Let's see, up here, I think that's just going to be a GCF. And so if I take a 6x cubed out of there, that's going to leave an x squared and a plus 4. And then remember, this is the prime one. When you have a squared plus b squared, you can't go any further. It's still going to cancel, but careful not to try to factor it where it doesn't. And then this one is also going to be a GCF. Probably if you guys were doing it, you would do it down here and try to figure out how it factors and then figure out its prime. I'll just show it right here again for space. So if I take out a 4x squared on each of those, that will leave behind an x squared right here, a 2x right there, and then 4x squared into 16x squared would leave me a plus 4. And from there you'd go what multiplies to 4 and adds to 2, and you wouldn't find anything. And that's okay, because it's this part of the cube formula that doesn't factor, so it's just going to cancel. So I can cancel that, and cancel the x squared plus 4s, and cancel the minus 2s. The numbers are kind of strewn everywhere, so for me, you can either try to do it in place, and at least gather it up in your head if you don't do it physically like I'm going to do here. But if you think of it as 2 times 6 is 12, x cubed is x to the 4, and then that's it for the numerator. Downstairs I have 3 times 4 is 12, x squared, another x to the 4th, and x plus 2. So then that helps me see 12s cancel, x to the 4ths cancel, and I'm just left with this kind of floating x plus 2. But that has to be under a 1, so we can always think of the numerator if it cancels out as just a 1 placeholder. Where you'd see that is like 5/10. So when we reduce that, we think of it as 5 times 1 over 5 times 2, and it's like the 1 and the 1/2. Okay, I realized I updated this problem since I printed these. So here's the one from the notes. I'm going to write this as, I'm going to maybe bring my x's together. I should probably rewrite the whole thing. So we'll do this. And again, if you can do it all in one step in your head, that's totally cool. But because this is the first time people are seeing it, I want to make sure I show my steps. Okay, so now I've flipped this fraction over, and then I would probably do this right here. I'd look at the 8 and the 24, and I think 8 goes into 8 once, 8 goes into 24 3 times. And then 49 and 35, I can knock a 7 out of there. So 7 goes into 49 7 times, 7 goes into 35 5 times. And then I'd gather up my x's and y's, put those together, and then cancel from there. So 3 times 7 is going to give me a 21 up top. I got 6 x's, and 1 and 4, so 5 y's. Downstairs I got a 5, x and x for x squared, 5y, y to the 5th, y to the 3rd, y to the 8th. And so the 21 and the 5 are done, because we did those back here. So I got 6 up and 2 down, so that's going to leave me x to the 4th up top. 5 up over 8 is going to leave me 3 downstairs. And then this one, these are difference of squares, so those are okay. That's a 5, 2, that's okay. This one, magic, I'm going to go 2 times 9 and do a little scratch work over here and then bring it together. So we got 2x squared plus 9x plus 9. So 2 times 9 is going to be 18. I need 2 numbers to multiply to 18, add to be 9, so 3 and 6. So I can do 2x plus 3 and 2x plus 6. Right there, I'll knock out that extra 2. And I got 2x plus 3, and that'll be x plus 3. Okay, so factoring everything over here in place, difference of squares, that's going to be 2x plus 3 and 2x minus 3. Another difference of squares, that's going to be x plus 2 and x minus 2. What multiplies to 6 adds to be 5. That will be x plus 2, x plus 3, and I'll just copy this one down. So 2x plus 3, x plus 3. Cancel, and whatever survives, that's our answer. So we got x plus 2's, those can go. 2x plus 3's can go. X plus 3's can go. So it just looks like right there is what's left. So final would be 2x minus 3 over x minus 2. Okay, number 9 looks terrible, but it's actually not that bad. It's all the factoring you can do in place, so it just looks bad because of all those extra letters. So just starting up on this first fraction, I'm going to have a minus, we're looking for what multiplies to negative 4, adds to be 3, so negative 4, positive 1. And remember, when we have the squareds on the ends, we just have to do an extra letter back here. So this will go a plus b, and then a minus 4b. And just to kind of show how this all works, a times a is a squared. We get plus ab outside, minus 4ab on the inside, so that's our 3ab, minus 4b times b, so there's our 4b squared. So same basic, 1, negative 4, just toss in the other variable. So down here, this would go a plus 4b and a minus 4b. Numerator on that one's going to be multiplies to 10, adds to 7, so 2 and 5. So a plus 2b and a plus 5b. A squared minus b squared, that's the formula, so a plus b, a minus b. And then this is a division, so I'm going to bring this one up. So multiplies to 20, adds to be negative 9, is going to be a minus 4b and a minus 5b. And then this is now the denominators, and that's going to be a plus 5b, a minus 5b. And once we get all that written out, we just cancel everything we can, and then what's left is going to be our answer. So there's minuses are gone. Let's see. Plus 5b's are gone. Plus minus 5b's are gone. AB plus AB. And I think that is going to be it. So what's left is right here. A plus 2b. A minus 4b. And that's going to be over a plus 4b and a minus b. And so that would be the end of it. You can't factor any of these and they're not the same, so you just have to resist the urge to try to cancel some b's or something. The other thing is no reason to multiply it out. It's perfectly fine to leave that in factored form and actually preferred. Cool, so that concludes 7.2, multiplying and dividing with rationals.